That's very remarkable because even in much, much smaller civil engineering projects that we do here on campus, for our buildings, we are almost required to nail down every detail associated with the building before the first, trench is dug or first brick is laid. But you're telling me that one has to take a more flexible approach to these large projects. It's a little counterintuitive, isn't it?
Yeah, for a small project, maybe the extent of variation in the properties of natural materials like ground, soil, rock is not significant. So, your design, if it is rigid, it will work. But in a project like Chenab Bridge, which covers few kilometers, you have huge variation in the weathering of rocks, their properties, and then also what you're seeing on the surface is not the same as what is inside those slopes. And the kind of project you're building is huge. It will impose large amount of stress on the system. So you have to be very informed about, like, you're going to have surprises in the project, and your design footprint, what you have in the beginning, may not work. So you need to keep little scope for adjustment at every stage of the project.
It sounds to me like at least the Chenab Bridge project was as much about what was under the surface. It's a spectacular structure when you look at it, but there is as much under the surface as there is steel and concrete that is visible to the naked eye outside, isn't it?
Absolutely, because large amount of time in this project was spent on understanding what is inside these slopes and stabilizing these slopes and making them ready for the loads that will come by live running train. So, to make the foundations as support for these piers, and to make that arch, which is unsupported for almost half a kilometer, lot of geotechnical engineering is gone inside this project, which is most critical in this project.